There we go. Perfect. Okay, so let's get going with shading Venn diagram. Shade the given region. So if I ask you to shade A, what is that? What would I have to shade? Malcolm? Or do you have a question? Malcolm, you're muted if you're talking.
Sorry, my bad. I didn't realize I pressed my hand.
Oh, no problem. Okay. If I ask you to shade A, what am I asking to shade in this Venn diagram here? Gavin?
The entire A circle, even the part that intersects with B.
You got it. So all of that is shaded. That's all of A. Good. I want you to write down what this means. The next one. This next one is A union B complement. A union B complement. So the union means all of it, everything that belongs to either A or B complement. Now, that's something we haven't seen yet, but B complement just means everything outside of set B. That's all that means. B complement just means I wouldn't. So, for example, if I was asking you for A complement here instead of A, if this was A complement, I would not shade this, but I would shade everything else. All of this in B, all of this outside, all of this outside, all of that outside, just nothing. All of this A would remain unshaded. Okay, if I asked you for A complement. So think about B complement. That's everything outside of B. It's including this space here, right? So what would I shade to represent the union of either A or B complement? Hannah?
You shade everywhere beside this, like the moon shaped B, like including the intersection with the A.
Is this part right here, is that included in A union not B?
No. That's the only part excluded.
So is this part included?
Yep.
Because it's part of A, right?
Yep.
Okay. So first I would do this. I would shade all of A. Because if it's a union, it means it could come from A. And these things, even though they're also in B, are in A. So we have to include them as a union, right? Now, what else is included in this union? Anything outside of B. So we have to shade everything outside of B as well. But we don't include, like Hannah said, that section right there. So the only thing that's not shaded is that, basically. Okay? Let's think about what this means next. Weird. A double complement. A complement, complement, and B complement. I don't know why anyone would ask that, but basically, this is like the same thing as a double negative. Two negatives make a positive. So the complement of A complement means we're not talking about everything outside of A. We must be talking about A then. So silly. But that's Boolean logic for you. A complement complement is A and B complement. So this is a different kind of question because this is asking now for the intersection between these two things. So I want you in your mind's eye, if you need to use a pencil and actually shade this, you can. But I want you in your mind's eye to think, what would I shade for A? Well, that would be the same as up here, right? That's A. And what would I shade for B complement? That's everything outside of B. Now, once you've shaded those two things, what is intersection, or what is the intersection between those two shadings that you just did? Hannah?
Only the part of A that does not intersect with B.
Right. We can't have this part shaded. It's going to be the things that are in A that are also not in B. So this can't be shaded. That's what that means. Okay? Here's B. B is easy. Just shade all of B. No problem there. A union B. What would I shade for A union B? We've already seen that before, but Charlie?
I'm actually still a little bit confused with 3.
Okay.
If it's B complement, wouldn't that be the things outside of the or outside of the diagram?
See what I've shaded here? Did these things count as B complement? Are those things outside of B?
Yeah.
They are. Are these things also part of A?
Yeah.
So that's the intersection. That's the common things between B complement, not B, and A. That's these things here.
Okay.
Does that make more sense?
Yeah.
If I shade it out here, do the things out here belong in A? Are they common to A? No, right?
No.
The things outside here are B complement for sure because they don't belong in B, but they're not part of A, right? So I would not shade anything here. This intersection means common things, so it has to be in common between those two things we mentioned. Okay, A union B is just A, B, whatever, everything gets shaded. All of this, including the middle. What does this represent? Can someone please tell me what they think this means? Gavin?
A intersect B complement, which means everything, like the entire box, except for the part where A and B intersect.
So we don't want this. We want everything but this, right? That's the complement of A intersect B. A intersect B is the middle. So basically we shade everything except for that middle. Whoops. All of this but the middle. So that's the only thing that doesn't get shaded is that middle. Good. Excellent job. Okay. I'm going to leave this for you to see if you can come up with the answers to these. The answers are given, so you can always go back and check the solutions to see if you're right. But I want you to see if you can figure out how to do some of these. What is actually shaded? What's represented by the shaded area here? Sometimes it's easier to use the complement of an event to help you figure out what's happening, right? So, for example, this one is a really good one as an example to use the complement of an event. What would this shaded area be? Can someone give me an idea? What would that represent? Hannah?
B complement.
It's everything except for B. See how the only thing that's not shaded here is B? If everything else is shaded, then you could call this B complement, right? That makes sense. Okay. So I'm going to let you guys figure that part out. Let's try one of these. Number 2 from this one. This is L1, S1, number 2. A complement union C complement. That means everything outside of A, everything outside of C, and put them together because this is an or a union question. So think about what would be shaded and what wouldn't be shaded in this case. Try it yourself now if you haven't done it already. And think about what would and would not be shaded there. A complement union C complement. Taya?
Would it be everything but B?
Not everything but B. No, because B is still part, like if you look at this section right here, is this a part of outside of A complement? I think so, right? Because it's outside of A. Is this section here a part of C complement? It is. So it's also a section that's outside of C. So you would definitely shade this part.
So would you shade that? Then would you just shade in B and everything around, like leaving A and C?
You can't leave A and C either, because in this section, if you think about it, this section here of A, even though it doesn't belong to A complement, the things that are in here belong to C complement, don't they? Right?
Yeah.
because this is a union, we're trying to shade everything that matches this, basically. So you have to think about what region here does not actually have either one of these things in it. That's what you're trying to figure out.
Okay.
Okay. Hannah, do you have an idea?
Shade every part beside the intersection of A and C. Like the
So this part gets shaded.
and also yeah.
Does this part?
Yep.
Because all of that stuff is outside of C, isn't it? Right? What about this? Is this outside of A?
Yep.
Section here? Yeah, it is. What about this? Is that outside of
Yes.
A? Yeah. So that gets shaded. What
And
about outside of that?
all of
Outside
it,
of here?
all of them.
That?
Yeah.
Okay. All of that gets shaded. So we have all of this shaded now. What about this middle section then? Let's take a look at this part right here. Is this the union or the coming together of A complement or C complement? I don't think so, right? Because this is in A and it's in C, right? You can't shade this part at all. That doesn't make sense because it's not outside of A, it's not outside of C. It's in both. So we can't shade this, and for the same reason we can't shade that. Okay? So that's the only two regions that we leave unshaded here. Good. That's what I want you to think of when you're thinking of a union. It's everything except for something. What is it that we're not allowed to shade? And then that sort of gives you a hint of what you do need to shade. Okay? Let's try this. Different. This is A complement intersect B complement now. A complement intersect B complement means everything outside of A, everything outside of B, and the intersection between those two shaded regions. So let's think about that now. Everything outside of A, everything outside of B, and the intersection of those two shaded regions. Now, this one, I wonder if I can use, I'm going to use a pencil on this one just because it might be a little easier to see. Maybe not. If I have a working pencil, there we go. Jerry?
Wouldn't it be like all of C? You would circle all of C, including the middle, and also the middle part between A and B.
Right here?
Yeah, and also like everything on the outside.
And everything on the outside? Okay.
Yeah.
That's a really good guess, actually. I like that. It's not correct, but it's a good guess. Here's what I'd like you to do. And I want everyone to try this right now for me, okay? I am going to left shade everything that is A complement. Then I'm going to right shade everything that is B complement. And I'm going to do both of those right now and figure out where they cross, okay? So here's me just starting with the first thing, A complement. And that is left shaded everything that is outside of A. That's including this. All of this is A complement. So notice how I shaded to the left everything but A. That's what A complement means. Now I'm going to right shade B complement. That's everything outside of B. And that's kind of going to look tricky. But I can't include B now. I can include A though, can't I? That's outside of B. I'm going to include A. I'm going to include yeah, I'm going to include all of this, all of this, and all of this down here. That's everything outside of B. Now, this is the cross shading method, but I want you to understand that when I did the first one and the second one, anywhere that I've just double shaded, where I've shaded twice, has to be the intersection between these two, right? If I've only shaded it once, then it only belongs to one of those two things. So for example, when I shaded this part in B right there, that only belongs to A complement, right? It does not belong to B complement. When I shaded this area right there, that only belongs to B complement, but not A complement. I didn't shade this intersection at all, period, right? And so where in this diagram, where have I shaded actually twice or double shaded? Everywhere around the outside is double shaded. You can see it, right? How about this section right here of C? Is that double shaded? It is, right? The only parts that are not double shaded is this. And I'm going to erase those lines right now. That's the only section here, here, and here. Those sections in all of A and all of B that are not double shaded. So that's the region that I'm going to leave unshaded. Does that make sense to everyone logically? When we shade A complement one way and shade B complement a different way, we can see where the crossover happens. And wherever that we double shaded, that's where we're going to shade in this diagram. If you only shade once, we don't include it because that's not an intersection, right? That's not common. Gavin, do you have a question or just forget to...
My bad.
No, that's fine, no problem. Okay, tell me how to shade A complement then. Let's go to the next one. Gavin?
Just everything outside of the A circle.
Everything outside of A gets shaded. That's representing A complement. Good. All of this down to here, just not A. Good. Okay, so you get in the hang of this. Try this one down here, number 8. Try number 8. And I can see I'm running out of time, but that's okay. I'll just do one more example of this for today. So what we're going to have to do, now that I see that the time is near, tomorrow, and I was planning on doing this anyway, so it's actually worked out not too bad. The first part of tomorrow, I am going to teach you combinations. So for the first hour, we're going to talk about combinations. And your quest should only take you about an hour. I might give you a little more time to get it uploaded and everything. So I'll make it due by like 3:30 tomorrow. So you'll really have 2 hours to get it done, but an hour of class time to work on it. Okay, and ask questions. Hannah.
Oh, it's not related to this worksheet, but I have some questions from the progress check and practice test for Unit 1.
Okay. Can we, I actually have time right after this at 2:40. Can we take them up then?
Yep.
Is that all right? Can you stick around? Okay. Let's do this one together. A complement union C. So that means it has to be C. So automatically, because I see it's a union and there's C involved, I'm going to shade all of C. All of C automatically has to be included here. Has to be, because it's the union of something in C, right? Now, what is it a union of? Well, it's A complement union C. So now we have to think about, what does A complement represent? What else do we need to shade here besides C, in other words? Who's got an answer for me? Hannah?
You shade like all the outside and then a part of B. It's like just leaving the A, like the moon shape of A, unshaded.
What part of B do we shade?
Like just the part that doesn't intersect with A or C.
So does this get shaded?
No.
Does this?
No.
Is this?
Yes.
Yeah, because that's outside of A. So that's still part of the union of A complement and C. Good. That's it. So we just leave this little sort of half moon, semi, I don't even know what you call that, crescent moon. We leave that unshaded, but everything else gets shaded, right, for this one. Good. Excellent work. Well done. Okay, we're going to do one more example. And that example is going to come from, let's do, this. There's still 2 and 3 sets, but we're going to do this one. Okay, starting with number 1, it says to perform the below mentioned, Boolean algebraic operation for the given set of elements. A Boolean algebraic operation means tell me what the set looks like that represents B complement. So here are the elements. It's giving you all the elements. This is the universal set for U. This is set A. This is set B. So I'm going to circle those. And then it tells you it throws a bunch of numbers at you. And we have to figure out what would be involved in B complement. Let's start with that easy one. So the algebraic operation for B complement, or not in B, is everything outside of B. So it can't be 35, it can't be 22, it can't be 7, that's still in B, but it could be 15, it could be 10, it could be 21, it could be 1, that's outside of B. So we list them like so. 1, 2 is part of this. I see a 6 over here. I see 8. I see 10. What's after 10? 13. What's after 13? 15 there. Hope I don't miss any. What else? 21, 28, and 50, I believe. Just double check my work. Did I get them all?
I think so.
I think so, right? Okay. So, and if you want, you can just cross them off as you go to make sure you get them all. But there they are. The ones crossed off are the ones that are outside of B. So I have just performed a Boolean algebraic operation for B complement, and here is the set representing those numbers. Let's try A complement and B. A complement means everything outside of A, intersected with B. Well, everything outside of A are the numbers like this, not including the ones here in the middle. B are the numbers inside of B. Well, the intersection of those is just this right here. So we have 3, 9, 22, and 35, representing A complement and B. Any questions on that? Everyone okay with that? So I'd like you to practice this concept, and that is, how do you perform Boolean algebraic operations either by shading to understand what a Venn diagram shaded looks like, or by actually listing the elements that represent that operation. Okay, so you have to know both ways and understand both ways. Like I said, all the answers are posted, so try it yourself, try to figure this out, and then check your answers to make sure you're right. If it turns out you're not right, take a look at the answer very carefully and figure out why. What was it that you missed? Okay, and figure that out on your own. I'll leave it there. If there's any other questions about that, we can always talk about it tomorrow if we have a bit of time tomorrow. But I'm going to stop the recording there. If there's any questions that have come up, I'll take those. First, let me stop the recording.